Okay, so we're going to look at this next question over here to use, this is number 5, and I'm going to use this paper to draw a triangle with area of 12. So area equals 12 centimeters, and I know that area also equals base times height divided by 2. So some number times another number divided by 2 is going to give me 12. So what is that number on top going to have to be? If I divide it by 2 to give me 12, it's going to have to be 24. I'm going to have 24 divided by 2, which will give me an area of 12 centimeters squared. So my base times my height, here we go, base times height has to equal the 24 in order for my triangle to have an area of 12 centimeters squared. So that's the first thing we need to figure out. So what are the two ways, what are the many different ways I can get 24 with base and height? Well, I could do 1 times 24. These are just the factors of 24. 2 times 12, 3 times 8, 4 times 6. And there we go. Those are all the different ways we can multiply two numbers to get to 24. So a triangle with any of those combination of base and height is going to work. So let's choose 3 and 8 just for fun. So if I'm going to draw a base of 3, there we go, and a height of 8. So height of 8 is going to be 3, 4, oh, I moved this, let's move this down a little bit. I didn't go quite high enough. Okay, so all the way here, this is going to be my height of 8 right over here. But I can draw this line anywhere I want. As long as this top vertex meets up to here, that's my triangle. So I'm going to go way out here just for fun, and then I'm going to finish off my triangle. So there we go. We have a base of 3, and we have a height of 8. And I'm going to draw that with a blue line to represent the height in this case. Okay, so there we go. That's an example of a triangle with an area of 12, and that's for 5A. Let's go to the next page. Investigate the different ways you could draw a triangle that has double that area. So here we had an area of 12 centimeters. So we want to get an area of 24 centimeters. So we want area to be equal to 24 centimeters squared. And we discovered that basically the base times the height has to be double this amount. So let's go to the next page. So if we're looking for an area that's double, which is 24 centimeters squared, we discovered that because area equals base times height divided by 2, and because at the very bottom, in this case, we would need 24 centimeters squared, we would need to put 48 up here divided by 2 in order to get to 24. So our base times height has to equal to 48. Okay, so base times height equals 48. So we're looking at factors of 48 now. So 1 times 48, 2 times 24, 3 times, what is it going to be, 16, I believe, 4 times 12, 5 doesn't work, 6 works, 6 times 8 works, and that's it. So these are the different ways I can draw a triangle that has double the area. Let's see what we had before with the dimensions where we chose 3 and 8. And now we have 3 and 16 as an option. So notice, in this case, we kept the base, if we kept the base the same, but we simply doubled the height to 16, we could get double the area. So that's one way we could do it. We could also, instead, double the base. Remember, this is the base. We could make the base 6 and make the height 8. So keep the height the same, but double the base. So I'm going to do it over here so we can actually see over here and compare. So let's try the one where I double the base. So here, 3, 6, there's double my base, and apparently I can keep the height the same. And I'll actually just go right on top. So according to what we just looked at, this green triangle should have double the area of the red one. Let's see, area equals base times height divided by 2. And our base in this case is here, and that is 6. So 6 times our height, which is still 8, divided by 2. 6 times 8 is 48, divided by 2 is 24 centimeters squared. So that did, in fact, double our area. Originally we had 12, and now we have an area of 24. So if you want to double the area of a triangle, you need to simply double either the base or the height. Investigate the different ways you can draw a triangle that has 1/2 the area. So our original area was 12 centimeters squared. So 1/2 of that, area N, I'm going to call area new, is going to be 6 centimeters squared. Well, based upon our previous question that said that if we want the area to be doubled, we can simply double the base or the height. I'm going to make the assumption here that if we want it cut in half, if we want the area in half, we would simply have to take half of the base or half the height. And we can try that out and see if that's going to work. So we were looking at, let's go back to our example here. We had the original triangle was and I'll circle that, was a base of 3 and a height of 8. So I'm going to half the 8. That's going to be the easiest. And I'm going to draw this one in black. So I'm going to keep my base. I'm going to draw it right on top. There's black. But instead, I'm going to make a height of 4. And just for fun, I'm going to kind of draw along the same line, but only up to 4 here, and then connect it. So there's my black triangle. That's my third triangle. And according to this situation here, apparently, this is going to be half. So let's try this out. I'm going to clear some space over here, and we will try this out. So our area of our black triangle is going to be base times height divided by 2. Notice I'm writing it a little differently. That's okay. Our base is 3. Our height in this case is 4. I'm going to identify that here. That's our height 4, because if we draw a line from here to here, the green line, that's 4. So 4 is our height. Divide that by 2, and 3 times 4 is 12. Divided by 2, that's going to give us 6 centimeters squared. So yes, we did it. That is half of the original 12. So the black triangle is half of the red, and all we had to do was take half of the height. The original height was 8, and we've simply turned that into 4, and we've got half the area. We could have also half the base instead. Let's move on to number 6. Use 1 centimeter grid paper. Draw different triangles with base 4 and height 6. So I'm going to do some different colored triangles here, and we did this with parallelograms. Base 4, here's base 4, and I will draw my height. My height is going to be from here, 2, 3, 4, 5, 6. There's my height marker, and I'm going to simply draw a line parallel to my base. Okay, so I've got my base here, here's my base, and my base is 4. And I've drawn this line over here parallel at a height of 6. I can put my top vertex anywhere along this line here of the triangle, anywhere, and it's going to have a base of 4 and a height of 6, and therefore the same area. Let's try that out. So we'll draw one here. There's triangle number 1. I'll draw another one in green. Same base, but I'm going to move my top vertex over a little bit. I'm going to do another one in red. There's one in red, but I'm going to move way over here. And blue, I'm going to go way as far as I can go. Now these shapes are dramatically different, but what do they have in common? They all have a base of 4. We've proven that here. They're all overlapping. And they all have a height of 6. Because that top vertex that I'm circling here of all these 4 triangles lines up with the height of 6, which means they all have an area of base times height divided by 2. Just move this page down, which is 4 times 6 divided by 2, which is 12 centimeters squared. They all have the same area. All of these triangles, 12 centimeters squared, 12 centimeters squared, 12 centimeters squared, 12 centimeters squared, despite the fact that they have dramatically different shapes. And that's the point of understanding that as long as the height is the same, it doesn't matter what shape they have. Find the area of each triangle you drew, and that's what we just did. We found out that they are the same, and we're going to skip question number C right now. We know all the triangles are different because we can tell just by simply looking at them. Okay, number 7, the area of each triangle is given. Find each unknown measure. So find the base in this case. So we start out with area of a triangle equals base times height divided by 2. In this case, they give us the area. So we substitute for the area 20. And they give us the height. So we give 4 times b divided by 2. So some number b times 4 divided by 2 will give us 20. What number? Well, what number divided by 2 will give us 20? Well, this has to be 40. This top part here has to be 40 because 40 divided by 2 will give me 20. And 4 times what number will give me 40? Well, that's 10. So b, therefore, has to equal to 10. So our base is 10 centimeters. That's A. Let's look at B. Area equals base times height divided by 2. Our area is 24. Well, what's going to be our base? They've told us our height is over here. That means our base has to be this line because it's perpendicular. So our base is 6. We don't know our height. And we divide by 2. So what number divided by 2 will give us 24? Well, that's 48. So my top has to equal to 48 here. So 6 times what number will give me 48? Well, that's 8. 6 times 8 is 48. So my height has to equal to 8 centimeters in this case. And what's great about these questions is you can actually check your answers. Right? You can simply go back and say, well, let's see if my answer is correct. I can write this out. Area equals base times height divided by 2. The base was 6 centimeters. I said the height was 8, so 6 times 8 divided by 2, that's 48 divided by 2, which is 24 centimeters squared. And now I've checked my answer and found out that it's correct. Let's look at C down here. Extend our page a little bit more. C, okay, area, same thing, equals base times height divided by 2. Our area is 7.5 centimeters. Our base we don't know. Base, and our height we do know is 5. So base times 5 divided by 2. So what number divided by 2 will give us 7.5? Well, that's 15. 15 divided by 2 will give us 7.5. What number times 5 will give us 15? Well, that has to be 3. So B is equal to 3 in this case. And D, area equals base times height divided by 2. Our area is 60. Our base, in this case, is going to be 24 because the perpendicular line is to the 24. So 24 times a height, which we do not know, divide that by 2. So back to where we were. What number divided by 2 will give us 60? Well, that's 120. And then what number times 24 will give us 120? We'll get out a calculator. I believe it should be 5. 5 times 24 is 120, so it's 5. So H is equal to 5.